Okay, so this is the last video with the ambiguous case law signs. In the first two videos, if you watched them, you found that we had the first situation was one triangle because the other angle that was created was too big to create a triangle. In the second situation, there were no triangles because the information provided an invalid value for sine. That's kind of hard to say, and it was greater than 1, so there couldn't be a triangle. And so let's see what we get with this one. So I'm going to go ahead and I'm going to draw the triangle. Perspective, the triangle that I draw might not be to scale because I'm not really sure what the angles are. So once again, I just have this kind of pattern where I start in the bottom left and rotate clockwise and draw my letters. So side A is opposite angle A, side C is opposite angle C, and angle A is 28 degrees. So it looks as if when I'm looking at this angle, so here's my eye, right? Lovely picture. The side opposite is side C, and I get 10. Okay, well, and I have angle A and side A, so I'm going to use that for law of sines. So I have sine of 28 degrees over its opposite 6 is equal to, I don't know what angle C is, and that's all over 10. We're going to go through this again and cross multiply. Multiply 10 by sine of 28, and that's going to equal 6 times sine of C. Divide both sides by 6. I'm going to pull out my calculator, and don't forget, if you click this all in on your calculator, the 28 has to be in parentheses or your calculator is going to make a mistake. So I'm going to go ahead and walk through this, and I get sine. I'm going to shrink this a little bit, move it over here, and I get sine of C is equal to approximately 0.78. Okay, so that does work. I can take the inverse of that. So sine inverse of, let me clean this up a little bit, sine inverse of 0.78. So I plug that into my calculator, and rounded to the nearest tenth, I get 51.3 degrees. Okay, so if I go ahead, and that works, right? So I'm going to go ahead and redraw the triangle that I drew in the beginning, and I have A, B, C. This is 28 degrees. This is 10. This is 6. And I just found that angle C is 51.3 degrees. And that works. So I could do the whole 180 minus I could do the whole 180 minus 28, 51.3, and I have enough to find that angle. And once I find angle B, I could use law of sines again to find side B. That's not what this question's asking, but if I had to, I could. Okay, so what about the other possible situation? We got 51.3 degrees. This is a first quadrant angle. Okay? I'm going to change how that's written. So this is a first quadrant angle. And I know that sine is positive in the first and second quadrant. So what if I was in the second quadrant? If I was in the second quadrant, I'd have 180 minus 51.3 degrees. And if I do that, I get 128.7 degrees. Okay, well, this one works, so I at least have one angle measurement. So let me kind of shrink all this down, and let's redraw our picture. And I get A, that was 28 degrees. I got 10 and 6, and now angle C could also potentially be 128.7. If I put this in here, do I have enough out of the 180 to get angle B? I sure do. I can actually get an angle there. And so what that tells me is I have two triangles that can be created, and so this is our ambiguous case. The angle measurement that we found could be 51.3 degrees, or it could be 128.7. And when I place both of these angles into the triangle that we started with, they would both work. So there's potentially two triangles that work, and I have two triangles. And this is our ambiguous case. If I asked you to solve the triangle, you just continue to use lost signs in both situations, and you'd get the information side B, angle B, so on and so forth. And that is our ambiguous case.